Hi, everyone. I'm Susan Pritchard. I'm a fire ecologist with the University of Washington, and I work on a lot of fuel treatment decision support. One of the first jobs that I had actually was as a postdoc with the Fire and Environmental Research Applications team of the Forest Service, and they had me help design FCCS back in the day. So it's kind of fun to be full circle now, presenting a new version of FCCS and also describing why it's still relevant and why we've actually supported a web tool. So with that, I'm going to pass this on to Paige Eagle next, who is always great at designing really kind of easy to use or intuitive to use web tools. Oh, we can't hear you quite yet.
Hi. Yeah, so I am I with Brian am part of the team of redeveloping FCCS for the web for online, and I would encourage you guys not to think of it as a super complex tool. It actually, once you get into it, it makes a lot of sense in terms of how it breaks fuels down from top to bottom, from canopy down to the forest floor. And definitely the calculations behind the outputs are complex, but in terms of using it, once you understand, I mean, Susan made a guide in terms of how to actually collect the data for it, and it's all very analog. It just makes a lot of sense. So I think it can be overwhelming. Certainly, there are hundreds of inputs for a single field bed, but we put a lot of time. Our team put a lot of time into making a lot of field beds that represent a lot of parts of the country that hopefully can be found to represent what you need, and then you can build from there. And we're working on user guides now, and to resolve. I mean, Heather, that was great feedback in terms of people aren't going to use it if they don't understand it, right? Yeah, I agree. And so we're trying to bring everything we've done together into a nice, like, digestible packet that would help people with the on-ramp. And I'm a research consultant. I'm actually with UW, but I've been working with the Forest Service and the Fire and Ecological Research Applications Group since 1990, no, since 2003.
Paige and I discovered recently that we have worked as close colleagues now for over a quarter of a century, which is kind of cool. Yeah.
Fabulous, and also like you're like, oh wow, really? Can I have
Amazing. Yeah.
yeah,
So
I agree. That's fantastic.
I've had the
We're
pleasure
yeah,
of working with
we're
Paige.
in it. We're in it for the research, obviously, like like there's stuff out now that like uh, all the kids these days, it's all about job jumping. You have to job jump if you're gonna progress, if you're gonna get any raises, you have to keep going from job to job. We're a testimony to staying put.
We're like in it for the passion for wildland fuels.
Heck yeah, man.
So Brian, do you want to go next?
Yeah, sure. I'll try the video for a second.
Awesome.
Okay. Yeah, I worked on the coding of the tool, and I my normal job is like supporting the other tools also. Um so any kind of new features or bug fixes, any sort of programming related work, that's my area of expertise, I guess. And I've worked with Paige and Susan for about the last 5 years now.
Awesome.
Yeah. It's just such a privilege to have this team. So I will just say that while, people on this Zoom and then people that are watching the recording, just know that we are like here to help out. So Paige and Brian are super invested in this web tool and can make things happen quickly. It's just amazing having this development team. So my goal, I think I'm just going to segue right in, Heather, to talk about like what I thought that I would cover today, the why FCCS just a little bit, and then mostly on how to use FCCS. So we are delighted to be able to roll out this web tool with the class, and no pressure. If you find that that's not going to work for your specific project right now, I will still feel like it's great to introduce you to a tool that brings out a lot of the structural complexity of wildland fuels in a cool way so that we can talk through wildland fuels. So my goal today is to show you FCCS, but kind of unpack the fuel beds as well. So with that, I think what I'm going to do is just share my screen, and looks like I'll need to request sharing my screen really quickly.
There you go.
Awesome. And I decided that I would not further complicate life with a PowerPoint. We're just going to work off of this web tool. And I will say that to start out with, I worked on FCCS. It's called the Fuel Characteristics Classification System way back in the early 2000s. And our goal back then was to offer users a tool that would go beyond fire behavior fuel models like the original 13 and standard 40 fuel models to be able to not only calculate fire behavior, but especially to calculate fire effects. And so a nice feature about FCCS is that it can go from field sampling, where you're actually measuring down wood and shrub cover and shrub height, et cetera, into fire behavior and effects. What we've noticed over the last 20 years is that most people who are really using FCCS do it for smoke management. Like that is the best use of it. And I think that that's what I'm going to focus on for this presentation, but we'll show you a little bit of the fire behavior behind it too. Heather, you mentioned some conversations about smoke management training and whether you would want to train different features about FCCS. I think for smoke managers, one of the key things to get across is that when you're opening up land fire and picking up an FCCS fuel bed or opening up Blue Sky Playground and picking a domain, what's behind those two layers are FCCS fuel beds. And so we need a tool, no matter if it's kind of rarely used or commonly used, for people to actually customize those fuel beds and get a better site-specific value for especially prescribed burning. But we can also talk a little bit about smoke from wildfires in this tool. So with that, I think I'm just going to launch into how to use it and what fuels beds are. Does that sound good, Heather?
That's great.
Awesome. So we have this tool saying FCCS and consume, and all that I've mentioned so far is the FCCS part. So the fuel characteristics are on big display in this screen, and then consume is a tool that basically takes all of that kind of fuel characterization and moves it into fuel consumption and emissions calculations. So when you're using Blue Sky Playground, and you pick a domain like, hey, this is where my fire has been, either in a wildfire dispersion model, or this is where my prescribed burn will be. You have a fuel bed layer in the base of it. And then consume is actually used within Blue Sky Playground to estimate fuel consumption and pollutant emissions given day of burn scenarios. And then you run dispersion in Blue Sky Playground. We have worked really closely with Blue Sky to make sure that our fuel beds and also the equations are synced up. And the wonderful thing about a web tool is that now that we're moving into web tools, we can make sure that the base calculations are the same. You probably don't care about that, but we really do, because as it turns out, Consume and Blue Sky Playground are used by decision support managers. So if you were at Washington State wanting to apply for a prescribed burn, you'd actually be presenting your burn plan that included some pile emissions or even some consumption emissions from consume to be able to apply for that burn plan. So these tools are widely used, but the innards of them are not generally viewed. And so we had to come up with a web tool to allow people to do that if they wanted to. So with that, I'll move on to how we might go about it. I was thinking that especially for University of Idaho, I know that you tend to get students from all over, but I thought we would start by just kind of like, how do we start looking at the huge number of FCCS fuel beds available in the system? And
Can I ask a quick question?
anytime, this should be super casual. Yeah.
So I want to know just a little bit more about these FCCS fuel beds, about how they were made. I mean, like if there's a 30,000 foot view level of information of like what were these field collected or expert informed? How did they get developed in the first place?
Yeah, absolutely. So I'm going to click on this ecoregion map because I think it will kind of help with that question. And I'm really glad that you asked it. So when we were creating FCCS, we wanted to be able to support widespread mapping of forests, shrublands, grasslands, and a representative fuel bed for them. And so we did this massive literature review that included a lot of FIA, forest inventory and analysis plots for the forests, so that we could come up with best available numbers. In reality, they're a concatenation, a combination of plot data and expert opinion just to make them work. And so I'm a pretty data-driven field ecologist, and so that drove me crazy because I really wanted to use plots for everything. But nature is super variable. And so we had a hard time coming up with plots that made sense everywhere to be completely data-driven on these field beds. The reason why I'm showing this map, Heather, is that we quickly realized that land fire was being asked to move into smoke management, and the best tool for that really still is FCCS. And so we were asked to create a field bed to represent as many of the existing vegetation types in land fire as possible as kind of a starter for. So when you click on a pixel in land fire and look at the land fire FCCS layer, you get a starter for your fields. Any other questions on that? I loved it.
And that was in the early 2000s?
That was in the kind of later 2000s when we started working with land fire. Yeah.
And has any of this been, as continued research has established more information about these field beds, has any of that been continued to be updated as we learn more information about them?
The base field beds, no. So we did do some better validation of them just because there were some weird kind of expert opinion errors and inconsistencies in them. But we haven't actually had better data to inform broad scale replacements of field beds. It's been more about like people from Michigan contacting us and saying, your base fuel bed has way too much organic soil on the ground. Can you look at that and think about your crosswalk? But we haven't had, I think, funding or even data sets to do an overhaul.
Got it.
That would be cool. Yeah.
That'd be cool. Yeah.
One other thing I will say is that Brian is definitely a little understated on his skills. We are aware of the fact that we can start making use of more wall-to-wall LiDAR. And so if fuel beds actually could be updated just for canopies, we have an option of updating their canopy fuels based on better data. So we have scripting to make that happen, actually. And so we are kind of in conversation with Landfire about those options. Yeah.
Got it.
Yeah, great. So I'll move into, I was thinking that it might be good for us to think about being in a zone that's familiar to University of Idaho. And so we could pick either this temperate desert or temperate steppe ecoregion. And really ecoregions are just a way to kind of describe broad geographic regions. So you can see that we have coastal Washington and Oregon here, which is a more marine ecoregion versus inland. So I'm going to click on that. And what that did over here was give us, instead of 400 plus reference field beds for the entire nation, we now have 109. And then we could also move into conifer forest, going down to 24 fuel beds for this region. And then if we wanted to, I thought it might be kind of fun to look at fire exclusion, and that gets us down to 15 fuel beds that are kind of in that semi-arid ecoregion, and they have had some loss of fire, so they're probably denser. And so for this exercise, and stop me if you want a different exercise, because we can just kind of go on the fly here. But what I thought we would do is view this 208 Grand Fir Douglas fir fuel bed. Rogers used it for a number of exercises, so I thought we could view it. And so the way we do that is to click on the row 208 Grand Fir Douglas fir fuel bed, forest, not fuel bed, click view, and that actually gives us a read-only version, which is so nice because then we have kind of like the copy that remains the same, and then we could do it one more time, and that will give us a customizable version, so we can always like view what we've changed. So anyway, just a helpful tip if you like it. And then what I thought I would do next is just give you the tour of what is a fuel bed, what are some of the complexities of it, and how we change the inputs within this web tool. Wanted to point out that right now, the native units are English, just because this was originally developed by the Forest Service. If you want to work in metric, we certainly can. So that's where you can change that for the inputs and outputs. So then scrolling down, I'm going to start from the top with the canopy. And much like Blue Sky, if you guys have used it, our tool allows you to dig into layers. And so we have 3 different canopy layers: the trees, snags, and ladder fuels. And then going into trees, we also have some fuel categories here. So there's the overstory trees, which are broadly defined as the dominant trees. Mid-story is kind of that co-dominant intermediate layer of trees, and understory. What I thought we would do today is just kind of like explore how we would modify this to represent thinning. So it's been fire excluded. What if we actually move in and do some thinning from below, taking some of the small to medium-sized trees in that mid-story, and then leaving the larger diameter trees in the overstory. So what I will do here is just kind of change this one value, which is inconvenient. This is the total canopy cover of the entire fuel bed. And so if we are going to do some thinning, I'll reduce that at the end, but you guys can remind me to do it because I might forget. So what I was going to do is just say, let's go ahead and make this mid-story what we thin. And so we could reduce it to represent kind of a thinning where you leave some mid-story trees. Or an easy way to do that for a demonstration is just click the present button. So now we've clicked off that layer and it's vanished. If you made a mistake, you can click it back on and your values will come. But I figured that for right now, it'd just be kind of an easy way to show you that to you. This understory layer sometimes just has little seedlings, but in this case, there's some saplings. And I would actually probably, if we were thinking about thinning the mid-story, I would reduce these to not be there because we'd probably take them out too. So showing you how to do that, maybe we'd get down to a cover of more like 5% of smaller seedlings. So maybe up to 5 feet in height, and height to live crown, probably just 1 foot, and then density. Maybe that density would go down to, I don't know. I'm just making up numbers here, but showing you how you can edit these values. Species, we'll do that in another thing, but I'll show you then how to edit the species mix if you want. So coming back here, I've reduced the understory cover a little bit, and then the mid-story as well. And so we've got 5% understory, no mid-story, 20% overstory. And so the maximum that we could really have right now is 20% of total cover. So I'm just going to do that. So any questions right now, just to see how I'm kind of like working through a thinning exercise?
No, it's great.
Awesome. Okay. So moving right along with snags, we could also think about the same thing where there's just a few recently dead snags with foliage. So these would be the red conifers, if they are conifers. And in this case, they are. Maybe we'd also thin those too. So it just again made use of this present, not present button. We don't have any, this is called class 1 other, which just means that they're recently dead, but the foliage has dropped, so there's sound snags. And then we have class 2 snags. You can see there's a tooltip here that have shed their fine branches, still have coarse branches and bark. And then there's class 3 snags, which are really rotten. So we're going to just keep those as habitat. And then the final thing we'll do in the canopy is think about, are there still ladder fuels? Is there still that kind of enhanced crown fire hazard? With 20% of an overstory and all that mid-story removed, I would say no. And so I'm going to take off the vertical continuity and take off present. Does that matter for smoke? No. So I just made some changes that matter for crown fire potential, but not for smoke and not for prescribed fire. And so if your application is only for the surface fuels, you probably only want to work with the surface fuels, but I just did an entire thinning. Show you a little bit more for shrubs and grasses. So the grasses and other herbaceous material here. We have a lot of complexity, but you probably won't want to work with it. So it's very fine to just have one shrub layer. So the primary is the main shrub layer. And then we have an optional secondary layer. You can see it's not populated with this fuel bed, or you could really quickly turn it off if it is. Herbaceous, we have some sedge in here and some calamagrostis, so a little bit of grass and sedge. And then we do have a secondary layer. If you didn't want that complexity, you could just take it out because you just want to have simple shrub and grass layer. So here, what I would say is if we're doing some thinning, maybe I would reduce the shrub cover and height. You could optionally, if you had better information about biomass, so the loading, you could put it here, or FCCS calculates that for you. If you have different species mix, there's a couple ways to work with this. One is that it will give you that this one has thin leaf huckleberry. The princess pine is another word for Camophila umbellata and spirea. Maybe you don't have princess pine. You can actually right click on that and delete that row. And I'm just going to show you that you could have 50% of the huckleberry and 50% of the spirea. As long as they add up to FCC, I'm 100% FCCS, it's good. So that's how you update species in all these various boxes. I just figured I would do it for shrubs. And so shrubs can give you a little bit of smoke, not much, but some. Grasses are really there mostly for fire behavior. So again, if you have like 100% grass layer with a couple feet, you're going to have really fast fire, and FCCS can respond to that. So I'm just pointing out the fire behavior. Wood, definitely important for smoke, and we account for a lot of different types of wood in FCCS. I think that this is definitely a great feature of FCCS is that we can go ahead and enter in surveys if we wanted to, except that we do ask for like this fine wood cover and fine wood depth. I'm here to tell you that only matters for surface fire behavior calculations. You don't have to worry about it at all for smoke, so you can disregard it. And again, Paige, I'm kind of thinking like this might be a good way for us to also support user cases within our user guide eventually. So here, again, if you knew that the thinning operation gave you more slash, maybe we double it and say that 1 hour, the fine wood, again, there should be a tooltip here. 1 hour, we need to work on that tooltip, but it should say 0 to 1/4 inch diameter fine fuels. 10 hour, 100 hour, I'm just trying to double them to show you that thinning might actually increase those fuels. 8 here, but maybe we wouldn't increase the large logs in this case. Again, you can edit species if you want. And then I really like this web tool. I think that it's showing you a lot of information. One thing we can do is represent that we've recruited a lot of stumps, and how many. You can actually go back up and account for them. So you could go, how many mid-story stumps did we just like totally obliterate there? Our mid-story trees, 90, and they had a DBH of 15. Let's go ahead and put those into the stump layer because they're going to matter down the road for smoke. And so here, height, reasonable estimate of stump at 2 feet, that's fine. Density, we can move to 90. In diameter, we could go to 15. So pretty easy to go from a thin to kind of represent renting different stumps. If you feel like this is a field bed that has been 10, 15 years following a thin, they would go into rotten, and it would matter a lot for smoke. And so it'd be really important to get them in. Sound stumps are not going to be really available to fire right away. So this distinction between sound and rotten is important. We don't have lighter pitchy stumps per se in the Pacific Northwest, but a really big deal for smoke management in the Southeast, where like longleaf pines, I think that slash pine too, I don't know the species as well as I should, definitely have more of that pitchy stump that can burn for days and cause smoke problems. Piles are so fun and complicated. I'm going to just quickly show you. We don't have any here, but if I showed them, we could edit a group and voila. I don't know if you guys have used the pile calculator at all. You have. I can see this.
Well, I'm not sure if the students in this particular class have, but
Okay. Yeah. This is Paige's awesome tool. It's like a standalone piled biomass calculator tool that she developed with Clint Wright back in the day. But if I wanted to, I could just say that these are Idaho piles. And perhaps we really only have 2 per acre that represent the, like if you've got the whole tree harvesting of the trees and you pulled the trees to the landing, we need to represent some machine piles that are going to be burned within this unit at the same time. So we could think about a complex feature of the piles, but you can really choose which side, what looks best for your landing pile. Lots of options here. I might just choose one that feels a little simpler to describe. So width for landing pile could be, I don't know, like 30 feet. Height, maybe 10. And then length, let's see, I did width wrong. Let's do 10 by 10 by 30. So just kind of giving a dimension. This is funny, but estimated pile that volume that is soil, you might really not know. This might be something that managers fine tune after time where they're like, oh, look at that. When we machine pile, we have a whole kind of pile of soil right underneath them. So I'm going to estimate that that pile volume is a little less just because we pile up some soil underneath. So that gives you that. And then if your piles are mostly like logs, you could choose this highly compacted clean piles with large logs, or maybe that's more of this like short needled conifers from the mid-story and a lot of tops. That's what I'm going to choose because that's kind of what we did with thinning. And then very quickly, we switched from, you could see FCCS mostly does scientific names. The pile calculator does not. But I know we were working with Grand Fir. And so I'm just going to go down and just for time's sake, give us all Grand Fir for the pile composition. And then because we've got some estimated pile that's volume, thinking about machine piles, rolling material in soil, I'm going to say that it's a little bit dirty. So, and then I'm going to save. And voila, now we have tons per acre of dirty loading. That's what that means. Yeah. And sometimes we do chuckle at the clean versus dirty and very dirty. It sounds funny. So yeah. So anyway, we could do more piles, but I'm not going to right now. One application that we could really think about is that maybe you have dispersed hand piles and you're really wanting to have a complex prescribed burn unit of like, okay, so I've got some logging slash, now I have some hand piles and I have machine piles. All of those can go into a fuel bed if you want to represent them. So I'm just going to finish out here because it's feeling a little long. But with litter, we already have 89%, which is seemingly highly accurate here on litter. Maybe go up to 100 after thinning and raise the depth to 1 inch, because this is not like ponderosa pine. If we had ponderosa pine, maybe we'd have more than 1 inch of litter. And then we can edit the litter types too. So if you felt like we had something other than grand fir or Douglas fir, and instead had some mix of like ponderosa pine, there's a long needle pine, or lodgepole pine, which would be a short needle pine, you could update the relative cover there. But I'm just going to cancel out of that. And then the final is really important to smoke as well. Litter is important to smoke, but you do not want to miss out on the duff. And I think it's important to mention that if we were to inadvertently try to use fire behavior fuel models to estimate smoke, we'd be missing a lot of important things, and this would be one of them. So here we have a cover of 90% duff, 1 inch of like an origin of dead moss and litter. Sphagnum is really an Alaska feature, so you can always trust that in the Pacific Northwest, we're going to be in dead moss and litter. So I'll just select that again. So there's that. And then lower duff is important to look at too. We've decided that this field bed does kind of pack a punch. We've got 1 inch of really highly compacted duff, and that's the lower duff, and then 1 inch of lighter duff. And so you're getting 2 inches of duff that will create quite a bit of smoke. So we'll keep those there. Two last things about ground fuels is that if you feel like you have tree mounds where you've had enough fire exclusion, where you're getting bark chips and especially litter around the base of trees, that's where basal accumulations come in. So these are estimated. There's not that many of them. There could be more, like we have more than 4 trees per acre. And so it's saying that some of your trees have these tree mounds. We're estimating a radius of that material where it's mounded material and a depth of that mounded material and the type, which is needle litter. So seen that. And then squirrel middens happen. I've seen them in Utah, Colorado, Pacific Northwest, but especially Alaska, and they can be really big and kind of big hassle for smoke management. Silly, but true to have squirrel middens in here. So, all right. Any questions? Heather, I know I went briskly, but I wanted to just give the overview.
No, it's really helpful. Especially those tooltips are really helpful there.
Yeah. Did you hear that, Brian? The tooltips are really helpful.
Yeah. Now I would just need to know that they were there. As I look through this, one of the things, how websites, they'll have that, like the first time you go on them, they have the thing that like makes you go to each step. That could be a thing that would make me know that. Because I did have a question developing one of them. I can't remember now, but like, what do you consider a stage, like different class of snag? And then you covered that, and I was like, oh, tooltip. I probably would have noticed it if I was really hovering around.
That's super helpful. We would love to get those comments if you guys do end up using FCCS and have more of those kind of usability things. Bring it on. That would be great. So, all right, well, I think I'm just going to round out by showing you how to run FCCS and consume. So I'm going to click on this button. Can you see the pop-up? Did that show?
Yep.
Oh, okay, good. Because sometimes in Zoom, you're like one window. All right, so with FCCS, I'm going to ask you to ignore quite a bit of this because we're not going to pay attention to fire behavior. FCCS inputs for a day of burn are all about fire behavior. So I love this feature of FCCS where you can actually do fire behavior and smoke at the same time, but we're just going to move on to consume. So here we're planning a prescribed burn in this recently thinned fuel bed. So kind of like get ourselves in that. We could change the season if we wanted to. Right now, fall seems very appropriate. Our fuel type is this kind of western region that comes up with the fuel bed. So you can look at these, but yeah, that seems good. And then with the moisture level, let's just go very dry. Did that change the inputs? Yes, it did. I just wanted to double check because I couldn't see. So we're going to do very dry. We're giving you some kind of options for fuel moistures, this is a refinement. And I really want to point this out, that managers said, you know, please let us change how much of the duff layer actually will burn, because Consume is overambitious with burning duff. And so we allow managers to shift how much of the duff layer might be available to burn. That could be considered cheating, but I don't think of it that way. I think of managers being able to really kind of work with this tool and get it to be more reliable than just saying, oh, hey, Washington State, all this stuff burns in model results, but we know that's not true. So anyway, maybe enough said. Consume is not a smart tool. We don't know how much of the canopy would burn because it's not actually taking a fire behavior run. It's more about this day of burn. So if you're expecting a prescribed burn to not touch the canopy, you can keep the canopy input at 0. If you think some of the trees would still torch, you could change it. But right now I'm just going to keep it at 0. Shrub, if you're thinking that you're going to have like a really efficient prescribed burn, go ahead and put shrub blackened at 100%. But if you feel like it's going to be patchy, you can change that. Piles, they tend to like have 90% of the material tends to burn and 10 doesn't. That's what Washington State guidelines are too. So I would probably keep that unless you know better. So and then output units, you can view all of your inputs in English and then outputs in metric if you want. I'm just going to keep them all in English for this one. So getting outputs generally does not take very long. And I want to show you what that did. I love what Paige and Brian did. So basically, you now have this user fuel bed, this 208U1 that you can download as your custom fuel bed and save it on your hard drive. We're not going to do much with that today because I don't want to go too long. But what we can do is come down here and view results. So FCCS will immediately give you a change in rate of spread, flame length. I personally absolutely love this graph. It's showing you the base fuel bed and the layers of LLM stands for litter lichen moss, wood is orange, herbs are yellow, and shrubs are green. It's showing you the sum of their total energy release, the reaction intensity, but also their contribution. And what we've done here is input more wood into the system because we've cut trees down and created logging slash. And that's why we've got higher reaction intensity. And we know it's coming from that wood. So highly intuitive, but sometimes it's really helpful with the public to kind of show like, this is what we're doing with our field treatments and how we're reducing that reaction intensity, that energy release. I'm going to skip over the potentials. If you guys have any interest, you can follow up with me. I'm super happy to do another one of these. FCCS is great accounting system. And so you can see that we've got total above ground biomass that includes tree stems. And then we mostly, except for the rotten wood, divide it by half to get at carbon. So if you want to have carbon accounting, we have a graph for that. And you can also see where most of your carbon is in the system. We can see ground fuels. That 2 inches of duff did matter here. And then we have wood and then canopy. And then we can move then finally into smoke management outputs. And here we have consume. And so once again, because we have this like nice fuel accounting system, we can look at consumption by stratum. So where is the most consumption in these 2 fuel beds? Not surprisingly, ground and wood. We have more consumption in the thin unit just because we've taken out trees and created a lot of surface fuels from that thinning. And then PM 2.5 emissions, love this too, where you can see where your problem fuels are in terms of total PM 2.5. If you're interested in dispersion, these outputs, if they're spatial in Blue Sky Playground, can then go from total emissions into dispersion scenarios with Blue Sky. So right now, we haven't coupled this web tool with Blue Sky, but we really want to, where users could customize field beds in FCCS and then port those over to Blue Sky. Pretty close to being able to do that at this point. So yeah. And then some other scenarios. If you wanted to, you can actually remove some of these layers if they weren't the important things on the graph. So I just wanted to show you that these graphs are interactive and you can take or remove different layers if you want to. Brian is amazing. So, by the way, so yeah, I'm going to stop there.